Hello and welcome everyone to today's workshop from Monolith to Microservice OCI at Modernization Adventure. Thank you for joining us. My name is Tara Van Cleve and I am a marketing event manager for the developer initiative here at Oracle. So today we're excited to get our game on and leverage an immersive 3D multiplayer game to show you how easy it can be to modernize and containerize your workloads. We'll also be recording the session, so if you'd like to try the workshop out at your own pace after the event, we'll be sending the replay out via the same email that you registered with for the event. If you have any questions during the workshop, please drop them in the Zoom chat and Q&A areas, and we'll be ready to help answer them there. We've also set up a channel in our developer public Slack called Workshop OCI at Modernization Adventure that you can access at the QR code or at bit.ly/odevrel_Slack. And we'll leave this channel open after the event to contact us directly with any questions as you're completing the workshop or to share resources and upcoming events with you. So today's workshop will be presented by Wojciech Pluta, Developer Advocate, and Victor Martin, Technology Product Strategy Director. But before I hand it over to Wojciech, here is the lab guide to follow along with the demonstration today. So I'm going to leave this up for just a few moments, and then I'll drop that bit.ly in the chat afterwards. All right, so without further ado, I'll hand it over to Wojciech.
Thank you, Tara. Hello, everyone. Happy New Year. Nice to have you on the broadcast today. Hopefully, you're gonna have some. We're gonna have some fun talking about some of the things that we create, the workshop that we created for our cloud world, and we're now releasing it to the public. So hopefully, you can deploy an interesting application and learn about the different runtimes that Oracle Cloud Infrastructure can provide. So my name is Wojciech Pluta. I'm part of the application development team. And I'm part of the technical marketing. And I'm joined by Victor Martin.
Hello, everyone. Thank you, Wojciech. Thank you, Tara. I will cover some of the demos, show you around a little bit of the UI and the steps to finalize the content if you finally decide to go and do it. So yeah, thank you.
Perfect. Thanks, Victor. So yes, we're going to be talking about moving from a monolith to microservice application, and we tried to make this as fun as possible. So we essentially honed some of the concepts around the 3D game, like Tara mentioned. So we have various deployment options that we're going to talk about, and essentially Save the Wildlife as we branded that experience a little bit. And we're going to give you a short overview of it in a little while. So in terms of the agenda for today, we're going to start, obviously, we did the welcome and introductions. We're going to give you a short overview of the front end and Save the Wildlife as a concept. And then hopefully we can have a little game of it, and then we can sort of explain and show you how it's made. Then we're obviously not game developers, but yeah, we try to have as much fun as it is. But main thing that the application can be used in various ways outside that as well. So let's move on. So Save the Wildlife. So how it started, essentially, as you can see, I think everybody as developers and people building stuff, we've been on various journeys as we develop solutions and develop stuff. So as you can see, it started from pretty basic blobs that were just moving around the screen and then having some sort of interactions with the 3D objects. And as we sort of were progressing with the demo and application, it's it became a bit better in terms of the adding some shaders and adding some additional capabilities and making it visually appealing to people. So hopefully we can run a front-end stress test demo, which is going to allow you to connect to the game. So I'm going to put in the chat an IP address that where we have our demo deployed, and hopefully everyone is able to join and have a little game while I explain stuff. So it's essentially the game itself, the concept of the game is pretty straightforward. We have this boat that is moving on the plane, and as we sort of move around and collect different objects, we getting points that can be either deducted or removed if we collide with the objects that are oh, thank you, Tara. I just did it to the panelists. Yes. So yeah, so this is essentially the game itself. So it allows us to have a multiplayer, multi users joining the game, and then you can see somebody joined, and people are expanding. So as the people are joining, the game world is expanding, the number of objects is expanding as well, meaning that the more players we have, there's potentially more score that we can get. We are time bound, which is essentially the main sort of constraint. So we have to collect as many objects within that specific time frame. Obviously, game logic is relatively straightforward. The controls, it's all about accelerating and de-accelerating. But what it does is essentially allows us to then capture the information about the time, where how many users are there, and then if we collide with the objects that are the wildlife per se, our points are being deducted, and all of that game state is being actually captured and continuously monitored, so that when the collision happens in one UI on one browser, it's obviously replicated across everybody's experience as they as they join in. And then essentially we have also a leaderboard, which is allowing us then to obviously exchange the data around the user and their score, and then create a leaderboard that gives us the some sort of overall status of how many objects were collected and so on. So pretty basic concept. The beauty of this, we're releasing all the source code for it. So whoever on the call decides to take this and leverage the connectivity that we have in networking, and then build a completely new front end, or embellish or change the front end that we have here, you're safe to do so. And like Tara said, we're sharing all the lab steps, as well as when you actually go there, you can get access to the source code and the GitHub project as well. So there you go. My time is up. My game is finished. All the people that are probably still there, their game is still continuing. So it's so yeah, pretty basic concept. But yeah, it was actually quite fun. Why? So what we used actually to build it, it's a web-based 3D a framework which is open source, called Three.js, which has many sort of additional iterations like A-frame and a couple of others. It's a pretty well-known framework. It's quite well supported by the communities, and it's being also constantly developed and enriched in terms of adding some additional capabilities. We really like it because one of the recent capabilities that's been sort of announced and worked on, it's a web GPU, which is allowing you obviously access capabilities of your GPU in web apps through the API. So potentially, the shaders and the realism of the 3D worlds that you can build are even more engaging, and it's pretty straightforward, JavaScript based and well supported framework. And like I said, it has also some iterations, which is like A-frame, that allows you to then build things that are, for example, VR compatible and so on. So then you can start building some other type of experiences that could be first personal and running in headsets and so on. I think the beauty of that is that, as part of the Oracle, we offer a complete cloud and, with flexible infrastructure that allows you to scale and, you can expect for it to be reliable, secure, and performant. And overall, I believe it's an innovative, development platform that has unique capabilities built in like Java and Grow, and supports obviously open source languages, frameworks, and tools like the Free.js that we just saw. We also have industry-leading integration services that you can then leverage, and Victor's going to talk about that a little bit more. We obviously have a fair bit of data capabilities within our offering, with autonomous database that we're using to capture scores that can meet your business requirements and needs and so on. On top of that, we have Apex, which is our low-code platform that is allowing us to build some other solutions and business related applications. We are investing in AI as well as our core infrastructure, so things like the web, like GPUs, like compute, ARM, and so on that can be leveraged and used for any sort of business needs that you might have. Then on top of that, we have observability and management and security and governance capabilities as well. That essentially gives you the sort of end-to-end full complete cloud solution. As it is with the games, for example, and any other applications, being present in many regions, being close to the potential users, end users, always helps with the latency and scalability. So we have a very good coverage across the globe in terms of the data centers. So depending where you're developing and where you're deploying your solutions, you have a various choice in terms of subscribing to different regions. And this is our latest presence in terms of all the regions and so on. So this workshop actually focuses on, as we said, the journey from Monolith to the microservices. So what we have in our offering, we have various runtimes available as part of the Oracle Cloud Infrastructure. So we have a bare metal and VMs offering flexible and scalable compute options. You can easily create and destroy VMs as needed, and you can choose a variety of VM shapes to meet your needs of your workloads. We also have containerized solutions. So in terms of the containers, we provide a lightweight and portable way to package and run application. With the container instances, they are ideal for workloads that can be deployed in multiple environments or need to be scaled quickly. And then I guess the star of the show and something that we really sort of emphasize in terms of the move from the monolith to the microservice and the application that we just were interacting with. It's all based on the Kubernetes. So we also have that as a container orchestration platform that allows you to manage and deploy containerized application at scale. In terms of what is Kubernetes, I think it's worth always to kind of assume nothing. So it's an open source system that is helping and kind of cloud native de facto runtime platform that simplifies deployment on cloud native of cloud native applications. In terms of Oracle offering, we actually have a managed Kubernetes on Oracle Cloud Infrastructure that is leveraging the power of Kubernetes at scale and also allows you to actually, create a fully managed service. Victor, do you want to jump in for now?
Yeah, sure. Yeah, we can jump into the next slide if you want. So one of the interesting things about the Oracle Kubernetes engine, OKE as well called, is the built-in management. So we are going to explain a little bit more in detail later, but the idea is that you have the control plane and the data plane, and you decide how much Oracle is going to take responsibility for, and the other part is up to you to give you the flexibility. All of that is ready for auto-scaling, and it will help you as well to keep your Kubernetes cluster up to date by just clicking a button. So it's pretty safe, and you can keep your Kubernetes cluster very in the latest version. And regarding scalability and reliability, we can spin a Kubernetes cluster in a few minutes as part of the content that we are delivering today. You will do it with Terraform, but you can also do it through the UI. I will show you a little bit later on that. Limitless scalability. There is like 2,000 nodes that you can create, so pretty impressive. And also, if upon request, we can even grow to a bigger number of nodes. And it's highly available by default because the master nodes are responsibility of Oracle Cloud. We will handle all the high availability for all the internal components. Price and performance, you pay for what you use, so only for the worker nodes, and it's a very competitive price performance that you can test it out there from this content. Predictable and consistent performance because it's running on Oracle hardware that is optimized for these workloads. Flexible and extensible, we will cover some of the examples, but there are many plugins that might be very interesting for you, integrations with the load balancers as well. And then the security. Everything is connected with the identity and access management system from Oracle Cloud, both from the management of the platform, but also on the role-based system internally on the Kubernetes cluster. With that, we can go to the next slide, and cover a little bit of what I was mentioning before. There is the control plane and the data plane. The control plane is basically the API server that contains endpoint, an API endpoint. That is the way you communicate with your Kubernetes cluster. You do requests, like for example, deploy this application, and Kubernetes will manage the deployments that are running on Kubernetes nodes. The other one is controller manager and the scheduler. Both are responsible for knowing what is being executed where and do the best use of the resources behind the scenes. And the etcd, that is the database that is storing all the state and the desired state and the real state and trying to match both all the time. On the worker nodes, you have several options, but basically they run the kubelet, that is like the agent, and then a few other piece of softwares like the container runtime, that is the one that is running containers, and kubeproxy, that is a way to communicate through the control plane and the worker nodes between them. They are based in compute instances. You have a variety of shapes from bare metal all the way to GPUs. That allows you to specify, depending on your workload, what type of containers are going to run in specific nodes. One example would be a normal general purpose service that can run in general purpose compute. But also you can train your data science models, machine learning models, and you can also do that in a specific GPU node pool that you can create. And with that, we can go to the next slide, where we'll go into the details of starting from the top, like the identity and access management that I was mentioning, all the policies, groups, and the access to the worker nodes, if that is the case with a Bastion. All of that is handled by the identity and access management of Oracle Cloud. You can also connect with third-party identity providers. That could be a federation from other systems that can be automatically integrated in who can do what in your Kubernetes cluster. On the left, there is integrations with DevOps, OCI DevOps, and Resource Manager, that is for Terraform, and Terraform as a service. Basically allow you to create a Kubernetes cluster and also deploy and move from source code into running container instances in your Kubernetes cluster. Networking is as well integrated. So all the security list, all the firewall policies, let's say, they are all integrated in Kubernetes and understand all the networking fabric from Oracle Cloud. The worker nodes, as I was mentioning, bare metal all the way to virtual machines with ARM, Flex instances, and also GPUs and HPC for RDMA. On the next is the governance, and it's fully integrated with the monitoring, logging, and auditing services from Oracle Cloud. So just by creating a Kubernetes cluster, you will benefit from all of this. On the right side, we have the load balancer at the top, and you can create a load balancer, a flexible load balancer that is integrated with your Nginx ingress controller inside of your Kubernetes cluster, and everything is very easy to set up. This is the example that you can take from the code already. And there is the persistent volumes for all the storage, depending on what type of information you want to store and how you want to handle that persistent volumes. Everything is integrated as well. So block storage and NFS, like file storage, all will be available there for you. Container images, this wouldn't be completed if you cannot publish your images, your container images in a container registry. So Oracle has a private container registry that you can use to publish your images, and then a vulnerability scanning and also signing those images for security. And with that, plus the use of key vault, a vault where you can store your secrets, and the overall infrastructure behind the scenes that manage all the data as encrypted data will keep you out of trouble. And with that, I cover more or less the out-of-the-box integration with OCI services from the Kubernetes point of view. We can move to the next slide. The flexibility is about the control plane and the managed services that you can use. So we have the virtual nodes on the left side. That is the most of the box worker nodes that you can deploy, and basically means that you don't have to worry about them. You ask Oracle Cloud to create a specific virtual nodes with a shape, a number of CPU and memory, and after that, Oracle take care of that. It has a doctor that is checking for nodes and checking if they are healthy, and if not, it will be replaced automatically. And that is all for you. It's kind of the most platform as a service for Kubernetes. In the middle, for a little bit more flexibility, you have the managed nodes, where the responsibility is shared between you and Oracle Cloud. It gives you access to the nodes, but at the same time, you can decide when to roll out a new version and things like that. But you still have access to those services, to those nodes. And the self-managed, that basically you configure them and you are responsible for maintain them and keep them up to date and in synchronization with the master nodes. More control, more flexibility, depending on the cases. You can do very detailed operations based on that. It's all up to you. And moving to the next slide, we can just talk a little bit about the architecture. So, Wojciech, I'll cover a little bit. You have the browser.
Sure.
The browser will be going through the load balancer to the ingress controller inside of your Kubernetes cluster. That will first fetch the static content from the web server that is running inside of Kubernetes. And after that, it will start executing that code on the browser and create new connections to get more information from the server. In that case, behind the scene, we will have a Redis and a coherence, Oracle coherence database, and an autonomous database to save the score. So in the Redis is for the public subscribe of a WebSocket server. Everything on this game works with WebSocket servers. So it's full duplex communication. And that is very useful for this type of real-time games. So we receive information about all the players all the time. That information about where other players are and what they are doing is stored in the Coherence, Oracle Coherence Community Edition. And finally, a Java service is running the score that basically will store everything in a relational database. That's kind of the overview. The Java application is a Spring Boot, so that would be interesting for you. I'm not sure if I'm missing something. We'll check.
I think it would be maybe worth, and sorry to put you on the spot, the stuff about obviously the type of the deployment that we use in terms of the Kubernetes, and it was obviously customized, right? So can you just maybe talk a little bit about that?
Okay. And also, I start to see some questions on the Q&A, so I will cover them as well during the call or directly answering on the Q&A. So feel free to ask any question at any point. Regarding, Project, your question, we use Customize. There are several ways to deploy into Kubernetes. Basically, the idea is to talk to the API server of the Kubernetes cluster and tell the server run this application, and this is the topology, those are the YAML files, all the information. And that will be the most manual way, just using kubectl, apply my configuration. And that will tell everything about your application to the Kubernetes cluster. Another approach, alternative approach, will be using Helm charts, that is like templating. That gives you a little bit of flexibility in terms that you can create templates that will change depending on some variables that you can pass. So that will be my dev environment, my test environment, UAT, and production, and you will play with those variables to get the best deployment that you need depending on the environment. That would be one example. We are using Customize because it's kind of like the trend is going in that direction. It's fully integrated with kubectl at this point, so it looks like it's integrated with the platform itself, the vanilla Kubernetes framework. And that means that it's interesting. And it's interesting because it's the aggregation of those YAML files what matters. So basically, you will have a based system that will apply to all of them, and then you will specify specific YAML files to modify that. It's easier to reason about these systems because it's kind of like an aggregation other than templating and using dynamic variables. And that's what I like from Customize, but definitely you can use the approach that you want. So feel free to explore Helm or Customize and pick the one you want.
Perfect. So we have one question. I have one more question, but we have one question on the chat, which let's try to answer live. If that's okay. So, which use cases are ideal for Redis versus coherence? So, yeah.
That's a brilliant question because both are in memory databases. So the reason for us using Redis is for the public subscribe. So imagine that you have several servers. They keep connections in the WebSocket protocol, and they will be connections that are kept alive. And that means that one node by itself don't know how to broadcast to every single customer, every single user of the application. And we use Redis for the public subscribe. We publish an event saying we need to broadcast this message, and that message will go to the Redis. The Redis will get informed to all the subscribers, and that will be broadcasted to all the users connected to the WebSocket servers, regardless of what node you are connected, because you can scale from 1 to 10, for example. So that's the case for the Redis. And the library that we are using behind the scenes is Socket.io, and that library has a plugin for Redis, so it was handy, and we have Oracle Redis as a service. So that will be one of the updates that we can do. It came out recently, a few months ago, and that will be one use for the Redis. Redis can be used as an in-memory as well. In this case, we use Coherence because it's one of the other Oracle databases that is getting a lot of traction and is very popular. Coherence is pure in memory and gives you great results. And we are using that for the specific use case of storing the state of the game, where every player is and what they are doing. That is exactly where the difference between Redis and Coherence in this case. And just for completion, Autonomous database is taking care of the score, who score has been added depending on who is collecting one of the items inside the game.
Yeah, yeah. So obviously we talked a lot about the Kubernetes, but can we obviously we as part of this workshop we looking at the different runtimes, right? So we use customize and to deploy and automate the deployment through overlays and so on. But we also have obviously elements of the VM and more kind of traditional sort of three-tier application. Do you want to talk about a little bit, I know we're probably going to go a little bit into details, but the high level, the use of things like the Terraform, Ansible, and that kind of flexibility of pretty much deploying the same application using that.
Yeah. In our case, it's very handy to have Terraform and Ansible because it can automate everything for you. It's interesting because you don't really need to get the details of how to create things on Oracle Cloud, but you will see them created, and then you can modify them. But basically, Terraform, just covering the basics, of course, but Terraform is an infrastructure as code. So meaning that you will write code that is representing the infrastructure you want. And then you will ask Terraform to deploy in Oracle Cloud, and that will create all the calls to the API, Oracle API, depending on the region. It will go to the region and create all the resources for you, wait for them to be created, and give you the output saying, I create all of this for you. The interesting part is that that state of what is being deployed can be in a shared place, and that will be Resource Manager, one of the OCI services, and that allows several people to work on the infrastructure at the same time. And it's interesting for, even if you have to create a test environment, you can run the whole infrastructure, run the integrated test, for example, and when you are done, you destroy the whole infrastructure without leaving anything behind. It's pretty handy because with cloud, it's endless.
Yeah.
You can create
And you can
a
schedule
lot of
those as
resources.
well, right?
Yeah, keep them nice and tidy. Terraform will help you with that. And Ansible is when you have created the compute instances and you want to install things and provision all the applications, all the frameworks, all the libraries. You can use Ansible that basically does a SSH connection and provision things called jam, install, whatever Redis or Coherence or install libraries that you need, and then also get the code inside of the machine and then run that, either a Node application, a Java application. We have both examples already there in the platform, so you can take a look how it's done. And that will be for virtual machines. And then we move to container instances that we use a little bit of scripting and then Kubernetes. So you can get a taste of the different ways of deploying from the traditional virtual machines, container instances, that is kind of like an instance that can run containers, very simple, but very effective. Some of other services use that for leveraging that capability to run specific pieces of code. And then Kubernetes with Customize and all the tools that you can imagine for a cloud native platform.
Perfect. Yeah, let's move on to that section because that's probably where people are probably interested to see and learn more about. So thanks, Victor. So as you can see, there's quite heavy reliance on the networking communications. Obviously, we dealing with some sort of concurrency management in terms of the users, joining in and each of the either shapes in terms of the VM or the pods and nodes talking to each other. It's quite important to consider that, there's been this page essentially did a quick cloud transparency platform comparison, and within that Oracle tends to be coming up as the most competitive on pricing. So whenever you need to deploy anything that is heavy relying on networking, our cost is definitely very competitive versus our competitors. So now introducing the lab itself. So yeah, everything that you saw, we packaged up for you to play with, explore, improve, change, or learn about. So all the concepts are available for you to explore through our Live Labs portal. And essentially, this session is all about, us talking about the lab. We're not expecting you to finish all the steps, but what we do is just kind of talk about the concepts and so on. But what you can find, there's a lot of different workshops, and majority of them are free and available for you to play with. Some of them allow you to set up them and use our environments, while others, like this one, that would give you the chance to actually deploy it on your environments. And as part of this session, you're going to get some cloud credits that allow you to explore and play with the technology and see how it deploys. So you can actually access that workshop. It's live already, and you can get started with it through that portal. There's a bit.ly link at the top, and I believe Tara's going to share it, and I already shared it as part of the chat. And to actually go there, all you have to do is just find the lab, and then to click run on your tenancy when you see the green, click on the green button. And that way, it's going to take you to all the individual steps in terms of the labs, and then into our GitHub repo that allows you then to start deploying and start looking at different deployment options. So from the overall hands-on overview, this is essentially what you can expect from the lab itself. There's going to be lab one. It's all about going into this monolith deployment, where you initialize the infrastructure through the Terraform scripts, and you can do it in a cloud share, or you can do it locally if you have it connected to your Oracle Cloud infrastructure account. And then we go through that and deploy the various images either through the container instances, and then publish that images to the container registry. And then, ultimately the final lab is about creating the database, manage cluster, and then deploying that, as we said, using customize to actually to your cluster, which is, a fun way to kind of interact and learn about this technology. We also provide actually all the cleanup scripts, so whenever you finish, it's possible for you to just go through your scripts and then clean it up, so your environment doesn't keep running and so on. So we're gonna now take a little overview of the sort of at the high level of the steps. We're gonna kind of between me and Victor, we're gonna talk at the high level of what sort of actions happen, but we also gonna kind of go into the UI of the Oracle Cloud infrastructure, and then show you sort of some of the things that are key to actually deliver that lab itself. Like I said, all of it is documented through the steps that we just through the link that we just shared. So in terms of the lab one, I know it seems like there's not many sort of tasks. However, there's a lot of stuff that's automated and happens. So we're using Cloud Shell, which is our through the UI, which is allowing you to run commands, clone repositories, and set variables, and then initiate any type of deployments. So that then allows you to interact with the resources and infrastructure through either automated scripts, or you can just do stuff using UI. So now Victor's going to show us a little bit about how that works, and so it's over to you, Victor.
Sure. So you should see my
Yeah, we can see
browser
it
already. Cool. This is Oracle Cloud Web Console, and one of the things is with the menu open, so you can explore all the services that are available. And one of the things that I want to talk about is, well, after the region, you can also see the Cloud Shell. And the Cloud Shell is a small, let's go to the Kubernetes cluster, for example. The Cloud Shell is a simple instance, free of charge that is running inside of your tenancy and is pre-installed with all the tools that you might need. So in this case, it's a nice way to be able to install things and communicate with Oracle Cloud without you having to install anything on your computer. It allows you to, if, for example, if you go to OCI, it will be in the latest version, and OCI is the tool for talking to Oracle Cloud. So one interesting thing is the interactive mode that will show you a little bit of the options we have. So if you put D, it will show you everything that you can execute. So if you, for example, want to list the databases, you can go and say, okay, OCI DB autonomous database, and we can, like, for example, list all of them. I'm not going to execute the whole thing anyway, but the idea is that you also have Java, you have Python as well, and all the interesting stuff that you can need. Everything can be executed in the content from this console, and that is a nice, tidy way to explore Oracle Cloud. Yeah, I think more or less that's the idea. It will store all the information you have inside. You can recover it from where you left. Another interesting thing, although you don't need it for this content, is the code editor. That is a Visual Studio Code editor that will pop up as well in the window in the website, and that means that you can also make some changes on the fly. And that's pretty much it for the Cloud Shell. It's one of
Yeah,
the
and I
tools that you can
pardon
leverage.
me, like we said, you can use the Terraform, you can use the Ansible to configure your environment. So it is pretty powerful. I use it a lot, and it's quite useful in terms of deploying and working with the resources as well. And like I said, the code editor allows you then to quickly change some of your configs, or change the type of resources if you want to introduce some other upscale or change the code and scripts. So it's quite nice little tool.
Yeah, one of the interesting things is that even you can connect inside of a subnet. So it might be a private subnet, but you can act as if your Cloud Shell instance was running inside of that subnet. For securities, you can actually get in there, take a look, do a SSH into another machine, troubleshoot, and come back from there, or just run it as a public network, right? Literally, it was a computer connected to the internet. So yeah, quite powerful.
Yep. So as part of like I said, the deployment here, we would run scripts, and then these scripts would create our individual resources in the VM as part of the lab one. In terms of the lab two, we have a couple of things where we start moving sort of in this container instance world, where we are containerizing our application, and then packaging it, pushing it to our container registry, and then essentially accessing that and deploying each of the containers, whether it was web or the score or the server. And then in that case, they working sort of in conjunction and communicating between them. We also adding the load balancer on top of it, so that way, like we saw from the flow, the user just enters one specific address, and then from that the application is orchestrating, where it is exchanging the data, and all the networking kicks in. So I think Victor's going to give us a little overview of the container instances now.
Sure. In this case, I will also share my browser. So back to the web console with the menu open, we can take a look to the developer services. From the top down, we have the Kubernetes cluster, but also the container instances and container registries. If we go to the container registries, we will have, as part of the guide, we will explain how to push images to the container registry that will be picked up by the container instances, but also the Kubernetes cluster. And in the container instances, we will have one already created as part of the scripting that we are asking you to execute. And that will be with specific details that you can take a look about the instance that is running all the containers. And also if you scroll down, apart from all the metrics of everything that is happening inside of that machine, you can take a look to the containers, and the containers will be two of the main services inside of this application, the web and the server, and those will be based on this image. So that's the idea, that you can execute containers inside of this instance that is managed by Oracle Cloud, and it's a nice way to execute few things. OCI DevOps, for example, use it internally to run as worker nodes. Basically, it will be executed for compiling your code and things like that. But you can do it for batch processing. You can execute even the whole application as we are doing here. And it's a very interesting tool.
Yeah, so I think it's worth mentioning. Obviously, if you are, partaking the journey to move from the monolith to the microservice type of deployment, you need to start considering, how do you going to move whatever you have running on your individual VM runtime, and then how you're going to containerize it, move it into Docker images and so on. I guess this is could be, depending on your application, intermediate step. However, it's not obviously as complete as in certain cases, the deployment to the Kubernetes would be. So in that case, we have the third lab, which is talking about how you can actually create your OKE cluster. We also manually creating database and then deploying the application, like I said, using the customize, right? And overlays. Do you want to show us a little bit of that?
Sure. In this case, I'm going to walk you a little bit about the creation of a Kubernetes cluster. So back to my browser, exactly where we left it, and go into the menu, back to developer services, and the first one on the list, Kubernetes cluster, OKE. And because I already execute all the content, we have our cluster, and that cluster will give you the information about the version and so on, more information there. One of the interesting things that you can do is also automatically, all the metrics are there for you, but you can go to the node pools. So in this case, we have a node pool with 2 active worker nodes, and that pool will be in a specific shape, and then you can scale up and down that node pool. All the information, you can get into the details of the specific information from that Kubernetes worker node, metrics about how they are and if they are healthy and if they are operating as normal. So that's the way you can explore everything on the Kubernetes cluster. One of the things we can do, and I want to show you, is how easy it is to create a Kubernetes cluster. So we click on Create Cluster. There is a custom create that will give you all the flexibility to pick absolutely everything. Let me
Sorry, can you just minimize? That would be great. Yeah.
This. And then the quick create. The quick create is very handy because it's going to create everything that you need to keep a Kubernetes cluster up and running in a few minutes. That will be all the networking from Internet gateways, the virtual cloud network, NAT services, and itself, the Kubernetes cluster and the worker nodes. So if I just go through the information that is required, a name, cluster docs, we can pick a version. The latest is 128.2, that's fine. And then you can select if you want the private endpoints or public endpoints, depending if you want to talk to the API server, that will be public, to the internet, or just private, and then you have to go internally by a Bastion host or with Cloud Shell configured to run inside of that subnet for the endpoint. Managed versus virtual, that is exactly what we were mentioned, the node type, what type of responsibility you want to take on your nodes. Manage will be that you manage them, and virtual will be that you rely on Oracle Cloud to do everything. In this case, we can also create the workers as private or public. I don't think there's a good reason to keep them public. So private, and then you select the shape, how much CPU and memory you want for them, and the number of nodes plus the instance, the image that you want to use. Oracle Linux is selected by default, and the how many nodes you want to run. In this case, you overview everything that is going to be created, and you click Create Cluster, and happy days. Everything is created in a few minutes. I'm going to cancel
Yeah.
this.
Can you just also go back to the cluster and just, sorry, very briefly show the
The one
add-ons
created above.
option?
Yeah.
Yeah, yeah. Oh yeah,
You're
that's
looking for
also,
this one, right?
yeah. I was
And
also wondering if you can maybe talk. We could show at the bottom that there's different add-ons also that you can enable
sure.
as part of the your clusters and so on.
Sure. So there is two ways to access the clusters. Well, to access the wizard that will allow you to easily connect. One is here with this button at the top, and that will be with Cloud Shell. And then you just copy that and paste it in Cloud Shell that is being executed here. I already have that configured, so no need to run it. But that is as simple as it is. You don't have to configure anything. kubectl is installed, and you just need to run that. That will create, if you pay attention. If we close that, something interesting that I think you should do is to go to Quick Start and the same button, doing the same thing. And then it will explain you that you can run kubectl version and then deploy a simple application. That will be the simplest application you can run. But that's a good exercise for everyone to just touch base with Kubernetes.
And can you
And then
just click on add-ons at the bottom? Yeah.
and then here you can
Mm.
take a look to other add-ons. Already predefined is the core DNS, that is the DNS server that is resolving all the names inside of the Kubernetes cluster. The kube proxy that we mentioned it, along with the kubelet. The kubelet is always is mandatory, so that's why it's not listing here. It's not an add-on. But the kube proxy can be disabled, but by default is here available. And then the native pod networking that is able to give you the underlying network fabric available inside of the Kubernetes cluster. Others, you can manage them here. Those are enabled, but you can have the database operator that allows you to, using YAML file definitions inside of the Kubernetes realm, it will allow you to create Oracle databases and manage the cycle, create backups, everything that you need. The same for certificates. If you want to establish a TLS, certificates between your services for maximize your security, Kubernetes dashboard that is basically a dashboard where you can see the number of pods, virtual nodes, what is being executed. It gets information from inside, from the logs inside of Kubernetes. WebLogic operator to manage the lifecycle of a WebLogic server, cluster auto-scaling, as simple as enable this and start working with the auto-scaling for the number of nodes and so on. And more to come. So that's really interesting. It's something you should explore because it allows you to do a cloud native application with very little effort on the parts that you are not interested. You want to run your application, your containerized application in a Kubernetes cluster and benefit from everything that Kubernetes has to offer. But at the same time, you don't want to really get into the details of how to roll out a new version in a master node in high available disponibility and things like that. Unless you want, and then you can also do that. But
Yeah.
it's really neat.
Perfect. Thank you, Victor. So just to kind of, we just have 5 minutes. So just so to round it off. So yeah, so as part of if you go through all the steps, you end up essentially with the application deployed and being able to pretty much use and go on the journey of using each of the either scripts or going through the UI to actually deploy stuff. Finally, there is optional cleanup. So whenever you need to clean it up, you can just run those scripts and it's gonna clean and remove all the all the details. Just kind of very quick info. We also did the same kind of application, but we used the OCI DevOps. We done that session pre-Christmas. So it's also available when that sort of takes you through the journey of using OCI DevOps to actually deploy your application to the through that automation and CI/CD pipeline. So recommend you to check out that if you want to sort of see how you can deploy pretty much same application but fully in an automated way. Let's see if there's any questions that people might want to ask. This is essentially all from us, but we're here to answer, or feel free to connect with us on LinkedIn or GitHub, and I'm sure we would be happy to have a chat with you. As well as Tara mentioned, we have a Slack channel where you can also interact with us there. Thanks, everyone.
Thank you all.